Welcome to Lesson 1 of the TypeScript and React Beginner's Guide. Let's start with the question every JavaScript developer eventually asks. Why TypeScript? Because by 2026, every serious front-end codebase has migrated, and the reason is simple. A typo like user.nmAE ships to production in JavaScript and pages you at 3 a.m. In TypeScript, the compiler catches it before you save. 0 runtime overhead, 1 tsconfig file, half the bugs. That's the conviction we're building this lesson. Here's the map for the next 30 minutes. 4 mental models that flip how you think about TypeScript. First, TypeScript is just JavaScript with annotations, stripped at compile time. Second, inference does most of the work, so you only type the borders. Third, strict mode in tsconfig is the floor. Anything less is JavaScript wearing a costume. And fourth, refactors stop being prayers and become guaranteed operations. Hit those 4, and the conviction shift happens on its own. Start with the first mental model. You write user.ts with an interface, type annotations, the works. The compiler reads it, validates every type, and emits plain user.js, type stripped, nothing left behind. The browser ships 0 extra bytes. That interface? It only ever existed at edit time, as a contract for your tooling. You pay in annotations. You get back autocomplete, instant error detection, and roughly half the bugs you'd otherwise ship. Now, the second instinct. Where to actually put your types. Annotating every variable is noise. TypeScript already knows that 5 is a number and Laszlo is a string. The senior reflex is to type the boundaries, function parameters, return types, API responses, module exports. Inside a function, trust inference. At the borders, where contracts meet the outside world, be explicit. Over-annotate and you bury the signal. Under-annotate and bugs slip through where it matters most. Which brings us to the single most important line in your tsconfig, strict true. That one flag flips on 7 separate checks, no implicit any, strict null checks, function type variants, the whole set. Skip it, and you're writing JavaScript with annotations, paying the syntax tax without getting the safety. Every senior team ships with this on. And the bonus line, no unchecked indexed access, makes array access return T or undefined, because index 5 might not exist and the compiler should remind you. And once strict is on, the real payoff shows up the first time you refactor. In JavaScript, renaming a property is grep, manual review, and prayer. In TypeScript, you hit F2 and every reference updates across the codebase. Type safely. Add a required field like email to your user interface, and the compiler immediately points at every call site that's now broken. Register user line 42, seed DB line 18, your test fixtures. 3 errors, 3-line fix, ship. That's the senior productivity unlock. So when someone pushes back on TypeScript, you'll hear the same 3 objections every time. It slows the team down. True for week 1, then 30 to 50% faster from month 2 on, measured by Microsoft, Stripe, and Airbnb. It adds runtime cost, 0. The compiler strips types and emits plain JavaScript. The browser never sees a type annotation. And it's just JavaScript with extra steps. Yes, it is JavaScript. That's the point. The extra step is a 100-millisecond compile that catches 60 to 80% of the bugs you'd otherwise ship. That's not overhead. That's the floor. Once you accept that floor, here are the 6 reflexes that turn a TypeScript user into a senior TypeScript developer. Never write any, use unknown, and force a type check before you touch the data. Type the API boundary. Every fetch response, every form submit comes in as unknown, validated with Zod, then trusted inside. Prefer satisfies over as is a lie to the compiler, satisfies is a check. Lean on discriminated unions for variant safety, brand your IDs so a user ID can never masquerade as an order id and actually read the error messages. they're precise. The error is the answer. Pin this slide. 12 patterns that cover 90% of your daily TypeScript. Explicit annotations versus inference, unions and optionals, function signatures, arrays, as const for literal locking, satisfies for shape checks without widening, and the two tooling moves that matter, TSC, no omit for pure type checking in CI, and TS expect error when you need a deliberate documented escape hatch. Learn these 12 and you're fluent. Now the failure modes. 5 mistakes every beginner makes once. Each one looks harmless. Each one signals a JavaScript mindset leaking into TypeScript. Any everywhere defeats the point. Casting with as to silence errors hides real bugs. Ignoring no implicit any lets the compiler shrug. Retyping what inference already knows is just noise. And treating types as runtime values, checking type of user against a type, confuses the two worlds entirely. Catch these in your own code. They're the leading indicators of TS misuse. Reading about TypeScript won't shift your conviction. Typing it will. 3 exercises, 10 minutes each. First, spin up a VTS project and intentionally write broken code. Watch the IDE catch it before you save. Second, rename a real JS file to TS, flip strict on, and fix the errors one by one. Every fix is a bug you would have shipped. Third, define an interface, then hit F2 to rename a field everywhere. That last one is when the IDE stops being an editor and becomes a refactor tool. That's lesson 1. TypeScript is JavaScript plus types. Inference does the heavy lifting at your borders. Strict mode is the floor you build on, and refactors become a superpower. Conviction built. Next up, lesson 2. We shape your data. Interface versus type. When to reach for which, plus the 5 daily tools. Optional fields, read-only, intersections, and unions. That's where TypeScript stops being a safety net and starts being how you think. See you there.